You have reconnect.
At Vishweshwaraya National Institute of Technology, Nagpur.
Sorry.
To provide a brief overview, I'm going to start with the background, the literature
So
review, case
the
studies,
screen is shared
identification,
now. Is it
historical
okay?
background, measuring method, simulation, result, discussion, and conclusion. India is known for its rich cultural heritage, and cultural heritage represents nation historical, traditional, cultural aspects which holds immense significance for its people. Currently, India have 42 tangible and 14 intangible World Heritage Site listed under UNESCO, and which holds universal outstanding values, which has authenticity and integrity. The main study of this research is to focus on archiving sound that has been deemed lost or forgotten, and to preserve and celebrate them as a valuable asset in our society. In India, forts and temples were designed with great mathematical accuracy from the acoustic point of view. So, one of that, any of the world's acoustically attractive spaces could be destroyed or damaged due to accident or natural disaster. The image shown on the slide is one of the famous opera house in Venice, Italy, which was completely destroyed on 29th of January 1996 by fire. But only its acoustics was preserved because an Italian acoustician preserved or documented the acoustic just months before the mishap took place. So it helps in recreating the same structure with the same acoustic values for recreating the heritage. So, in terms of literature's review, the sound plays a very important role in worship space, both at homes and temple. And sound is defined as that which resides in space and is considered as the fifth element and is perceived by the sense of hearing. In India, there are various sites which have musical pillars. For example, in Hampi, a researcher studied a spectral analysis of the musical pillars, which have unique feature. The acoustic marvels in Madurai temple is also known for its noise levels of 40 dB, which was recorded inside the sanctum area. The main characteristics of the sound in a temple space is defined by chanting of Vedic mantras, sound of conch shells, bells, and recitation of artis and stotram. So, the temple is the most characteristic artistic expression of in a Hindu philosophy. The temple mark in the map of India is are the temples with having the musical curiosities in down south. That there are three important sound spaces in a temple complex, which are defined by the first space is the central space or the sanctum area, which is also known as the Garbhagriha, where the ideal or the deity is placed. Where only a single priest is allowed inside the chamber, and he recites Vedic chanting. The second space is the Antaral space or the pavilion space, where which is dedicated for the worshippers, and various congregational activities takes place such as bhajans and kirtan. The exterior sound space is the third space, which has the processional pathway, which conducts traditional activities of such as palanquin or holy water bath also takes place. So these are the three main sound spaces in our temple complex. For our case study, we have selected Markanda Temple Complex, and it is located in the Chamorshi town of Gadchiroli, Maharashtra. It is a 12th century temple which is situated on the bank of Ganga River. It is also known as the Khajuraho of Vidarbha. The temple is not just a single temple, but it is a temple complex with which has 24 small scale temples. We for our study we have selected the Markanda temple, which is a mid-sized scale temple. For the temple complex is a rectangular layout of 39 meters in width and 30 meters in depth, extending from north to south direction, and provides a unique setting for our acoustic simulation. It is a pilgrimage site for Lord Shiva follower during the annual Mahashivratri festival. The volume of this temple is 427 meter cube and is constructed of basalt, black basalt with with sandstone. And for our study, we have used the Bruel and Care measuring system and recorded in the rack system. So the sound source was omnidirectional speaker connected to power amplifier, and we measured it using the handheld analyzer with a calibrated microphone. The data was recorded using the Dirac system. The plan of the Markanda temple demarcates of the three important space, Garbhagriha, the Antaral, and the pavilion space, also known as Sabha. The sound sources were placed in two main positions, the Sabha Mandapa, center of the Sabha Mandapa, and the second was the Garbhagriha or the Sanctum area. The receiver positions are demarcated with red, identifying of six measuring receiver positions were placed according to the conditions inside the temple. As you can see in the image, we see the sound source which is placed in the Sabha Mandapa, and the handled analyzer is placed in the Garbhagriha, from which we measured or the receiving receiver were placed. The sound source and receiver pattern was studied according how the kirtankars are seated while singing the bhajan and kirtan. The main focus is the DT direction, facing the DT direction. So the arrangement of the spaces was identified and studied accordingly. For this, we have also prepared a simulation model in SketchUp and imported in Odeon software. And similarly, we have placed the two sound source position as well as the receiver positions were marked in that temple. So we also calibrated and validated the temple using the two parameters of reverberation time T20 and clarity of speech C50, using the absorption coefficient and the scattering coefficient of hard wall surfaces adopted from the literature. From this graph, we identified that the measured and the simulated values are within the just noticeable difference as mentioned in ISO 3382 standards. So by this we can conclude that the temple model was calibrated and validated. For result and discussion, uh, we have studied for two sound source position. First is this sound source which was placed in the center of the pavilion. The second is the located in the sanctum area. So two sound source positions S1 and S2 were studied for occupied and unoccupied condition. As you can see, the result given in the two graphs have the occupied values are lower, obviously because of the absorptive qualities of the people in the temple pavilion area, which was employed in the computer simulation. The average T20 occupied value for sound source in the sanctum at the Markanda temple is 0.9 seconds, much higher than 0.72 seconds at 125 hertz for the sound source, which was placed at the center of the pavilion. So the values, the occupied values are lower as compared to unoccupied values because of the absorptive qualities. And 0.9 seconds was the highest value which was observed in occupied condition. The second parameters we studied was the clarity of speech. The clarity of speech have for Markanda temple simulation demonstrated in all frequency range. The sound source S1 has substantially higher spatially averaged C50 values than the sound source at S2. As you can see in two graph, the sound source located within the sanctum of the Markanda temple has lower clarity because of the sound source and the receiver position. The sound source was much captured in the sanctum area because of the coupled volume. The third parameter we also studied was the speech transmission index. The values for as have been stated from 0 to 0.3 is considered as bad, to 0.75 to 0.8 it is considered as excellent. By this results, we observed that for R6 position, when the sound source was placed at S1, that is the center of the pavilion, was lower was lower because of the sound source and the receiver position. Simultaneously for S2 position, it is above it is in the good speech intelligibility rating. So by this, we conclude that in Markanda temple, T20 occupied values are higher and clarity C50 values are lower at lower frequency. The temple enclosed pavilion have highly reflective and diffusive properties of basalt stone, which contributes to more immersive sound fields for worshipper inside the temples for musical ritual. And this suggests that prolonged decay can contribute to moderate reverberant sound field in Markanda temple. So the higher C50 values, the sound field in Markanda temple is conducive to musical rituals, and the subjective rating for in occupied condition is overall good. So by this we conclude with references. Thank you.
Thank you very much for the presentation. We are going to the third presentation now. I will stop sharing and I'm going to analyzing the acoustic performance of unglazed terracotta in an indoor office environment. Is it shared now?
My co-author Sangeeta will be presenting our research paper on analyzing the acoustic performance of unglazed terracotta in an indoor office environment, also co-authored by our professor Amalan Sigmund Kaushik. Noise is a concerning and prevalent issue in the built environment. Office spaces are subjected to multiple noise interruptions during work hours, like HVAC noise, background noise, human interaction, and so on. Acoustic panels are highly efficient method of noise control in the built environment.
If anyone
However,
cannot see the...
most of the acoustic panels available in the market today are unsustainable and have been discovered to adversely impact human health. Terracotta, an indigenous and durable material ingrained in the vernacular architecture of India for centuries. It is conventionally used for roofs, floors, and decor, but remains unexplored for its acoustic properties. Through this research, we aim to evaluate the acoustic performance of unglazed terracotta tiles as a salutogenic resource using the reverberation room method and impulse response method in an indoor office space. This research aims to encourage architects to consider terracotta as a prospective material for building acoustics. We intend to explore the architectural acoustics of unglazed terracotta, a sustainable and locally available material for increased quality of work and health in an indoor office environment. The two primary objectives for the research are to perform a comprehensive measurement of the acoustic properties of unglazed terracotta with a sound level meter and make a comparative analysis of the acoustic quality pre- and post-placement of terracotta specimens in the office. Coming to the materials and methods. It is crucial to design all spaces sensitive to acoustics, not just dedicated to musical and speech spaces. Nowadays, a greater attention has been focused on sustainable building methods. This comes with analyzing the acoustic and thermal performance to achieve a significant impact on the environment and human health and exploring sustainable acoustic options. Unglazed terracotta has high porosity in comparison to the commercial glazed wall tiles, which makes it a viable option to explore as an acoustic material. Coming to the methodology, the acoustic comfort property of unglazed terracotta is explored to analyze how the material influences the overall acoustic quality of the space. The scope of the research is identified through literature review. Parameters such as sound absorption, background noise, sound pressure level, speech transmission index, reverberation time, and noise curves are meticulously measured both pre- and post-placement of terracotta specimens using a Bedrock SM90 Class 1 sound level meter. Calculations are made using existing standard formulae like the Sabin's formula to understand the absorption coefficient of the tiles. An overall evaluation of unglazed terracotta is done to understand its acoustic properties. Standard tests are performed to analyze the acoustic property of unglazed terracotta. Reverberation measurements are carried out as per the standardized procedure given in the ISO 33822. The impulsive response method is performed for reverberation time RT60 measurement with the help of a clapper to measure the decays at the 1/3 octave band. The energy decay curves were then plotted. The measurement was taken multiple times to ensure accuracy. Speech intelligibility is measured with the STIPA Pro to measure the speech transmission index. A measurement of 60 seconds was taken to improve measurement accuracy. The STI analysis was carried out at a 1/3 octave band from 125 Hz to 4000 Hz. Background noise is measured using real-time analyzer at the 1/3 octave band to analyze the frequency values from 25 Hz to 20 kHz with a measurement time of 60 seconds per reading. Signal to noise ratio is measured to the sound pressure level of running speech. Each reading is taken for 60 seconds and a talk box is used to produce a sample running speech. The SPL of speech and background noise are calculated as well as the total LAEQ. The signal to noise ratio is calculated with the obtained value. Noise curve is measured to evaluate the noise levels based on sets of standardized spectral curves. Noise criteria standard values were derived to evaluate the background noise in the room. Coming to the equipments used, the experiments are measured with the help of the sound level meter Bedrock SM90, which conforms with Class 1 requirements. A fabricated clapper is used to measure impulse noise, and a talk box is used to dissipate sound during the experiment as per the requirement. Coming to the site location, the study was conducted in an office room on the second floor of the Department of Architecture at the National Institute of Technology, Tiruchirappalli, Tamil Nadu, India. The office measures a total area of 101 square meters. The existing office space had two windows on the 0.9 meter sill level and stack ventilation windows. Coming to the experiment, it was carried out in two phases. Phase 1 being the base case pre-placement of terracotta and phase 2 being the post-placement of terracotta. The base readings were taken from the office room in 6 different locations of 1.5 meters apart. A fixed microphone placed at a height of 1.2 meters is used for the measurement. A total of 10 decays are taken from each microphone position, giving us a total of 60 decays as per the ASTM standards. For the second phase of the experiment, readings are taken post-placement of 100 5-processed unglazed terracotta tiles of 0.625 square meters each. As specified in the ASTM standards, the tiles are laid out on the floor for convenience of measurement in an asymmetric pattern. 60 decays are recorded in a similar manner to that of the base case.
The background noise was measured first. The types of background noise identified were from the fans in the room, noise from the students and staff members from the floors below, and the noise from outside the building. LAEQ, LAF max, LAS max, LAI max values across frequencies 125 Hz, 250 Hz, 500 Hz, 1000 Hz, 2000 Hz, 4000 Hz, 8000 Hz and 16,000 Hz were taken, and the values have been provided here in the table. The measuring equipment was carefully placed 1 meter away from all surfaces and at a height of 1.2 meters from the ground as per standards. The next test was to identify the sound absorption coefficient of unglazed terracotta, for which RT60 values were measured. Using the sound level meters, RT30 and RT20 values were taken across 6 locations, 10 readings each with and without terracotta. These values were converted to RT60 and plotted in the graph format. This is the table and the graph of RT30 with terracotta. Next we have the values of RT30 with terracotta. As you can see, the RT30 values have reduced from the base case where terracotta was not placed in the room. This shows that terracotta has potential to become an acoustic absorber. The calculation of sound absorption coefficient was done using the Sabin's formula across different frequencies. Additionally, the noise reduction curve was also calculated and identified to be 0.063. The next test performed was the speech intelligibility test using STIPA. Speech intelligibility refers to how comprehensible the speech is to the listener. For an office environment, a value of 0.3 to 0.45 is considered poor, while 0.45 to 0.6 is considered fair. In this case, we can notice that there isn't much change in both cases, especially the further away the listener is from the sound source. The next slide covers the signal to noise ratio or SNR values. It is a measure which is used to compare the level of a desired signal to the level of background noise. Increased in SNR value is a good sign, as it means that the speech is more clear to the listeners. The next slide covers the noise criterion test. It is a new rating system that takes into account the distribution of noise energy across various frequency bands. The table below shows the recorded values. From these tests, we can conclude that unglazed terracotta is a textbook panel absorber. Once made into a product like wall and ceiling panels, with proper backing and coating, it has huge potential to function as a sustainable option for acoustic absorbers. Thank you so much.
Thank you very much for the interesting presentation. I am going to share the fourth if Dr. Reham is ready to handle this or not. I am okay. Dr. Reham, are you there? Okay, I think Dr. Reham not there. So the fourth presentation is cement-based composite with additive manufacturing technologies for sustainable architecture. A review PhD candidate Erem Gilan. Are you there?
Hello. Yeah.
Okay, I'm going to share your presentation now.
Okay, thank you. Hello everyone. I'm PhD candidate İrem Ceylan Engin from Kocaeli University Architectural Department. Today I will make presentation titled Cement-Based Composite with Additive Manufacturing Technologies for Sustainable Architecture within the scope of 7th International Conference of Contemporary Affairs in Architecture and Urbanism. First, I would like to show you the table of contents. The presentation will consist of 4 main parts. There are introduction, methodology, results and discussion, and conclusion. First section, introduction. In recent years, it is known that energy consumption and carbon dioxide emissions has taken a major place on the world agenda. Buildings known to be accountable for the almost 40% of global energy consumption and around 40% of carbon emissions come from the construction industry. To avoid high carbon emissions, traditional production techniques start to being replaced by additive manufacturing, also called AM, technology over the last 20 years and is known as 3D printing. 3D printing devices are completely electrolytic, thus they are emission-free. It is known that one of the most commonly used materials in the construction industry is cement-based materials. The process of using cement-based materials or concrete in 3D printing is commonly known as 3D concrete printing. With 3D printing, digital construction data is automated into production on-site with the help of robot assistants. In Figure 2, you can see the construction site photograph of Peko Group collaboration with Hyperon Robotics. This is an example of on-site robotic application of 3D printing. Compared with traditional manufacturing techniques, 3D printing reduces production time by almost 70%, reduces the use of raw materials by 70% and waste materials by 60%, reducing labor cost by 50 to 80% and requiring only a small team of 3 to 5 individuals to finish the project. So, cutting down on human labor can lower the total project cost by 50 to 70%. Also, eliminating human errors during construction and, most importantly, saving 35 to 60% of the total project cost by eliminating errors. Furthermore, compared to cast-in-place concrete, 3D concrete printing technology can reduce construction time from months or days to hours and improve sustainability and environmental impacts. Within the scope of this paper aims to investigate the development of 3D printer technology in the construction sector and to make predictions for the upcoming years. Using the systematic literature review technique, the development of the use of cement-based materials with 3D printers in the last 10 years has been investigated. Second part, methodology. A systematic literature review was conducted to identify studies on 3D printed cement-based materials in the literature. As the first step of SLR, these research questions were identified. The research questions are: what are the cement-based materials? Which cement-based materials have been produced and developed for use in 3D printers? Which properties of these produced developed materials were examined? And which properties of materials are intended to be improved? The included and excluded criteria of the research scope are shown in Table 1. Here you can see included criteria and excluded criteria. Included criteria, first criteria is studies on natural cement-based materials were published between 2014 and 2024. Excluded area outside the years of 2014 and 2024. Included criteria articles published in English, excluded criteria article published in a language other than English. Also included criteria concrete, cement, concreted earth-based composites, recycled sand, reinforced cements, geopolymers, lime-based mortars, reinforced cements, strain-hardened cementitious composites, gypsum, flexible FRP textiles, colonite, aggregate composites. There's all of them should have to include cement. Excluded criteria is studies involving other materials. Included criteria studies using 3D printer production methods, and paper studies on rheological behavior and mechanical properties and microstructural behaviors. 67 articles within the scope of the inclusion and exclusion criteria shown in Table 1 were examined. SLR findings. As a result of systematic literature research, 67 articles were found between 2014 and 2024 that meet the research criteria determined within the scope of the study. 57 of these articles are accessed via Science Direct, and 10 of them were accessed via Springer. You can see it Figure 5 and Figure 6. According to Figure 5 and according to our research, the most related articles were found in Construction and Building Materials Journal, second Journal of Building Engineering, and then Automation in Construction. Third part, result and discussion. Materials were divided in two main sections and categorized. These are cementitious materials and fiber-reinforced cement-based materials. Cementitious materials has two subsections. First one is concrete. This section includes studies on 3D printed concrete. Second one is other than concrete and includes studies on 3D printed earth-based cementitious composites, recycled sand, geopolymers, lime-based mortars, strain-hardened cementitious composites, gypsum and cement mortars, flexible FRP textiles, kyalanite, aggregate, and cement composites. Fiber-reinforced cement section also has two subsections. Synthetic fiber-reinforced cement includes mostly polymeric fibers, and a few of them are on steel fiber-reinforced cements. And natural fiber-reinforced cements includes plant-based fibers. As can be seen from the data obtained from the table, most of the 3D printed cement-based material studies was done on concrete. And Table 3 shows the papers in literature on 3D printed cementitious materials studied on improving the rheological, mechanical, and microstructural behaviors. It's divided in three main sections. First one is rheology. Rheology describes the deformation and flow characteristic of the material, which affects the pumpability and buildability of the printing process. So it's very, very important to the 3D printing process. Rheological properties include viscosity, yield stress, and thixotropy. Second one is mechanical properties. Although there is more mechanical characteristics like plastic shrinkage, dynamic mechanical analysis, or thermomechanics, scope of limitation of the study is only on tensile, flexural, compressive, and shear strengths. Third main section is microstructural behaviors. There appears to be more research on compressive and flexible strength properties of 3D printed cementitious materials than other ones. Table 4 shows the papers in the literature on 3D printed fiber-reinforced cement-based materials studied on improving the rheological, mechanical, and microstructural behaviors. The increase on microstructural behavior compared to the number of the studies can be explained by the necessity of investigating the mechanical locking and interface bonding of fiber and matrix material. Fourth part is conclusion. It has been observed that the studies have started to increase significantly since 2017, as you can see on the figure 6. Since 2017, an increase has been observed in the number of studies on fiber-reinforced cement, especially when we look at the natural fiber-reinforced cements. There's no study we found previous to 2016, and as a result of the literature research conducted within the scope of the study, it is seen that the studies on 3D printed concrete decreased in 2021 and 2022, but it remains widespread in general. And this all data indicates that cement used in architectural application through virus reinforcement and EM technology for environmental sustainability has become more and more widespread. Thank you for listening. And these are the bibliography. Thank you.
Thank you for the presentation. I am going to share the last presentation before to take the round table for discussion or for the questions. Professor Cindy Melissa, are you there?
Yes, I'm here.
Welcome, Doctor. I'm going to share your presentation now.
Thank you.
Good afternoon, everyone. We are Professor Cindy Melissa Godinez and Ana Gabriela Cruz, our research assistant, and our research is about upcycled prototype shelters for emergencies and disasters in Acapulco, Mexico. We are an active part of the research program of Monterrey's University at the School of Architecture. And we want to show how Acapulco was before Hurricane Otis. Hurricane Otis hit Acapulco on October of last year. And where is Mexico? Well, Mexico is between the Pacific Ocean, the Gulf of Mexico, and the Caribbean Sea. Mexico is prone to hurricanes and tropical storms that start over warm ocean waters during the Atlantic hurricane season. This season varies between May and November. The impact of hurricanes on Mexico dates back centuries. Aztecs and other indigenous groups and communities along the coast talk about the devastating effect of these storms. However, the documentation of hurricanes in Latin America and Mexico became more systematic with the arrival of European explorers in the century 15. One of the most devastating hurricanes in Mexico occurred in 1970, when Hurricane Celia made landfall near Tampico, causing extensive flooding and claiming thousands of lives. In 2005, Hurricane Vilma hit the Atlantic basin and caused significant damage along the Yucatan Peninsula and Cancun area. All these hurricanes had profound socioeconomic impact, hitting coastal communities that rely on fishing, agriculture, and tourism. Hurricane Otis was not the exception. It hit Acapulco last year and destroyed infrastructure. It caused disruption and essential services, deaths, and unlawful loss. Otis was a powerful tropical cyclone that struck Acapulco, that is a popular tourist destination on Mexico's Pacific coast. So Otis was an hurricane Category 5 with broad torrential rainfall and furious winds, leading to flooding, landslides, and structural damage. The storm severity overwhelmed local emergency response capabilities, quickly prompting widespread evacuation and emergency declaration. In response to this fact, Mexico has invested in various measures to enhance disaster response, including early warning systems, evacuation plans, and infrastructure improvements. The aftermath of Hurricane Otis in Acapulco revealed that the vulnerability of coastal communities to extreme weather events and the urgent needs for resilient infrastructure and disaster preparedness measures, it's really, really important. Recovery efforts involve a collaborative response from local authorities, government agencies, humanitarian organizations, and volunteers, focusing on providing aid, restoring essential services, and rebuilding communities.
Regarding the demographic context, as of 2020, Acapulco has a population of 776,566 inhabitants, of which 47.7% are men and 52.3% are women. Adults aged 30 to 64 represent the majority of the total population. They represent a 41.8%. In the last 15 years, more than 50% of the population has been in poverty at some point, and currently 34% of the population is in moderate poverty, and 16% is in extreme poverty, representing 50% of the population in total. And it should be noted that the percentage of population in extreme poverty in Acapulco is higher than cities such as Mexico City, which has a 4.7%, and Monterrey with 1.8%. This is important and should be taken into account to determine the user of a shelter and their needs. Now, moving along onto the proposal itself, the material proposed for these shelters is either a PVC or polyethylene tarp. Both of these materials are common and have negative and lasting effects in our environment. For example, polyethylene, which is mainly used in the packaging industry, takes a long time to decompress due to its composition, and the buildup is heavily problematic. It's estimated that 79% of the substance ends up in landfills, and after that, this waste goes through an oxidization process, which contributes to global warming and ozone depletion. This material releases greenhouse gases as a reaction to interaction with the sun and ultraviolet rays, and it is commonly consumed by marine animals, which causes health issues and even death, which damages these ecosystems, and consequently, smaller organisms such as plankton ingest polyethylene microplastics, fragmenting them even more, which is later consumed by larger species. And on the other hand, PVC, also known as polyvinyl chloride, is one of the most used polymers. It accounts for up to 10% of worldwide plastic output, and it's very popular due to the fact that it's inexpensive, durable, has good mechanical, chemical, electrical, and thermal qualities. However, it is also one of the most unsustainable and harmful materials due to the fact that its entire life cycle releases hazardous chlorine-based compounds from its manufacturing, usage, and disposal. This makes it one of the world's greatest dioxin producers, and it accumulates in water, air, and food chains, having serious health consequences, which include cancer, immune system damage, and hormone disruption. Now, for the methodology, Rhino and Grasshopper were used for the design and modeling of prototype for the shelters, allowing for the exploration through parametrization. Kangaroo was used as it acts as a physics engine within the design software, and it allows to simulate real-world behavior and integrates rapid simulation into the design phase, and it creates a very fast feedback loop. It facilitates the process of digital form finding, where the physical response of a model helps determine its shape. And Crane, which is a plugin that allows users to create origami structures, was used to employ some well-known patterns, such as the Yoshimura pattern. The following image shows one of the two base algorithms used. This first base algorithm uses Kangaroo, and it starts out with a surface designed in Rhino, which is then imported into Grasshopper and turned into a mesh. From this mesh, points are selected to function as anchors, and loads are applied to generate the form of the shelter. And then the mesh is cut and simplified. And finally, Weaverbird, another Grasshopper plugin, is used to create the framing. For the base algorithm using Crane, the Yoshimura pattern was employed, and the parameters that were modified were the size in the X and Y axis, as well as the count of segments in the same axis. Now, these were the results for prototype A. Caramba, a structural analysis plugin, was used to analyze each of the structures as a shell, using the same parameters for each analysis. These are the results for prototype B, prototype C, prototype D using Crane, and prototype E using Crane as well. To conclude, prototype B was selected as it shows less compression points and its morphology could allow for better rainwater drainage. However, in comparison to other designs, this prototype falls short in its modularity, as it cannot connect very easily to other shelters. And it's also worth noting that functional, structural, mechanical, and aesthetic details should be further punctualized to ensure comfort for its users. Given that this is the first phase of the project, further research should involve prototyping at a 1-to-1 scale with the upcycled tarp to assess its performance in real work conditions. And the goal of this research is to contribute to the development of sustainable and effective emergency shelters, not only for natural disasters, but also for other events or other contexts.
Thank you very much for the presentation. We are now almost, we have good time for discussion. Please, if you have any questions regarding the presentations, we are here to hear them. If you have any question, you can write them also down for the authors. So no, any questions? If you don't have any questions, I have some questions. Dr. Riham, are you there? Do you have any comments before I start my questions?
There. Hello, Professor.
Hi, how are you?
It's fine. Well, I don't have any questions for the authors. However, I appreciate all their efforts in their work. Have done great efforts, especially the last one with the simulation program of Grasshopper. I think it's important now to be up to date with these simulation programs.
Exactly.
Engineering, urban design, all fields. So, I encourage this type of research because it's very important now to use these programs.
To be more realistic.
Yes.
Yes, good point. Thank you very much.
Decisions, even in architectural field or civil engineering field, it helps in taking decisions.
Yes, it is correct.
Yes.
Thank you for your comments. I want to go to the second. I have one question for the first. I will write it down because he asked me to write the question for him instead of asking directly. I will write the question for the first for Chin. But let me to start with Apurva, PhD candidate. Are you there? Yes.
Yes.
Apurva, as I understood, you have a case study from Indian, let us say, traditional buildings. Yes.
Yes, Indian temple, heritage temple.
I didn't, maybe I didn't recognize or I didn't follow up. Is there any creeping in the acoustic? Because normally the Indian system has a very passive technique in acoustic, which is a creeping. Did you witness any creeping in the domes for the case study building that you analyzed?
Unfortunately, the temple design for the Markanda dome, the ceiling of the temple is tiered ceiling, and it culminates into a point. So basically, we have analyzed the internal acoustics basically for the temple. So we don't have sound inside the temple. So it was more of a reverberant inside because of the diffusive
How much was the
walls because of
reverberant
carvings, intricate. It was approximately for average for 500 to was 1.2 seconds.
Yes.
Yeah.
Okay, it was very interesting actually, because I have made some research about Indian temples when I was in India. I found this creeping system to let the audience hear the speaker from both edge of the conference room, without to let the people in between to hear what the speaker says, which were very interesting
May I know
point
which
for me.
case?
Redford,
Yes,
I
yes.
think Redford in
Redford. Basically, the sound acoustics of fort and in India we have basically fort acoustics is properly and was designed specifically for based on acoustic performance, but temple architecture is unexplored. So this was a new study that we could consider.
Thank you very much. Thank you very much.
Fort and temple seems to have different.
Yes, I understand. So for the cement-based composite, Erem, are you there? PhD candidate Erem.
Yeah.
So Erem, 3D printing, as far as I understood, they are heavily depending on the cement, yes?
Not heavily dependent on the cement, actually. 3D printing can be made with polymers, but in my research, it is concluded that cement-based materials, included concrete, has the highest rate. But not only cement.
Highest rate of using, you mean?
Yeah.
Yeah, but my question is, what do you think? If we stick to the cement, we are in the opposite side of sustainability. Okay, we are using some technologies, we are reducing the time, sometime, maybe in the future, reducing the cost with the 3D, but we have to focus more on non-cement material, like a binding material in concrete. What do you think?
Yeah, I think so too. But in architecture, as you know, cement is widely used and we cannot just easily give up on cement.
Yes.
So we have to make cement more environmental friendly, and this is possible using the 3D printing technologies or less emissions, less carbon dioxide emissions technology.
Yes, I think cement as a binding material and filler, the function of the cement is to adhere the things together. Maybe we can think about more eco-friendly filler materials to take place instead of cement. in the future if it is possible. But in the horizon until today, as you said, as you mentioned in your presentation, cement is the most powerful material to be used. It was very interesting, actually, the presentation and the data that you collect. It was valuable. Thank you very much for your participation in the conference.
Very much.
The last presentation, as Dr. Riham mentioned, it is really interesting, and it is really considered, should be considered when we are designing and thinking about the design. My question is for Dr. Melissa the things that I am thinking about, any alternative material instead of those plastics, because I think recycling these plastics also giving high emission to the environment. Or what do you think? This is just my question, came to my mind, to use different material, or these plastic materials, PVC materials, when you are going to reshape them or recycle them, it would also give extra pollution to the environment.
No, not necessarily. We have the laboratory, and we are, but this is a second phase of the research, because we are trying to mix the materials with other impact to have some resistance. So this is the second phase, and we will build inside the campus the prototypes in scale 1:1. So this is second phase of our research.
So it is very, very interesting, actually, and I feel it is productive research. I wish you all the best in the last stage, also in your process.
Thank you so much.
Thank you very much for all of the participants and audience. Dr. Riham, you are the chair. If you have anything to add to the session, you are welcome. Otherwise, I have to end the session and waiting for the time of the next session.
First, I have nothing more to add than what I have said before, that we have to encourage these simulation programs both in civil engineering and architectural fields, because it's very important nowadays. It saves also time after enhances the operation of buildings concerning energy, thermal comfort, everything. So I think it's very important, and in the next conference next year, inshallah, we can conference for be a direction for all authors to participate in this direction. So
Sure.
we can propose it
yes,
later
as a separate session.
Yes.
This is a good idea. We will say this to Dr. Horace. Thank you very much. So
Okay.
I will end the session now, and see you in the coming session.
Inshallah.
Okay.
Thank you all.
Thank you.
Okay.
Thank you. Bye-bye.
Okay. Thank you. Bye-bye.